The Zimablade is a compact, low-power single-board x86 personal server from Icewhale Technology. And today I'm going to show you some pretty amazing things that you can do with such a modest and humble device. From building a RAID-based NAS and a Plex Media Server to a full surveillance system built with Frigate, powered by this $24 TPU AI chip. And we'll also integrate it with your favorite home automation platform, that is, of course, Home Assistant. Now, the Zimablade comes in two versions. The 3760, which is a dual core up to 2.2 GHz, and the 7700, which is a quad-core up to 2.4 GHz. Both versions are based on the Intel Celeron Apollo Lake CPU, have dual SATA with 6G, 4K HDMI, and 32 GB of eMMC storage plus 1 gigabit Ethernet port. Now, if you pick up the NAS kit, you also get the additional 16 GB of RAM and this awesome rack for the HDD drives along with the required connections, making this entire setup really nice and compact. However, I wasn't really impressed with the specs, not at least until I saw this little thing right here, this PCIe Express 2.0 times 4 slot. It's not really fast, but we can pimp it with this device right here. But anyway, one thing at a time. Let's begin by creating a NAS first. Now, assembling the kit is pretty straightforward. You just insert the drives in the slots, secure them with a couple of screws, and then you connect the board to them. Now, this thing comes with CasaOS, where the OS part is only in the name, really. I mean, CasaOS is just UI sugar built on top of a Debian distro, which might be enough if you're an absolute beginner and all you really want to do is install a couple of apps. However, one thing that for me was a complete deal breaker is that it does not allow you to create a RAID for your NAS. I mean, you have no failover drive. And in my opinion, a NAS without a RAID is like a pizza without a base. So we're going to ditch this CasaOS thing and install the ZimaOS, which Icewhale developed, which actually is an operating system and allows us to create a RAID. We begin by downloading the ZimaOS from their website along with their recommended boot drive application called Balena Etcher. And then all you gotta do is flash a drive with it. Then you just simply go to the BIOS and select the USB connection to boot from and follow the instructions that you see on screen. Now just make sure that when it comes to selecting the drive, you select the eMMC storage, which is the 32 GB version. And then you go to your client computer, open up a browser, and enter the IP address. Now follow the instructions you see on the screen and ZimaOS is installed. Now, once installed, there are three things at least that we want to do. We want to create a RAID, we want to enable SAMBA and SSH, and we also want to set up the network, or at least just set up a static IP for our network. So, to create the RAID, click on Settings, Storage, and then View. Select the Create RAID blue button. I'm going with a RAID 1 because I want at least one drive for failover in case one of the other drive dies. Select Next. Choose the Use Recommended option, which basically just selects both drives, and click Next. Now, give it a name, whatever you like, and select the I am aware option, and then click Create. Now, give it a bit of time, and well, that's it. Your RAID is created. Now, all that's left is for the OS to finish the syncing. Now, next, we just need to enable SAMBA so that we can access, our NAS from Windows. And also SSH so we can remote to it. To do that, you just click on General. Scroll down and click on View under Developer Mode. Then switch on the dial for SSH and for the SAMBA service. You can also access the web terminal, which, by the way, works really, really well. Well done to Icewhale. In the same settings window, click on Network and then select the three dots right next to Ethernet. Choose Manual and add a static IP address. Just make sure that you have one available or you're going to lock yourself out. Now, when you hit Save, your window is going to freeze for a bit because it's, well, literally saving it. So just close that tab on your browser and open another session with the IP that you've chosen. Now, the simplicity of the ZimaOS and even the UI sugar of CasaOS is what appeals to a lot of people. I've seen many YouTubers raving over this thing. So let's do a media server next. However, as always, if you like what you're seeing, don't forget to show some love and subscribe, and cheers for that. Now, today I'm going to be doing Plex because I always do Jellyfin, and I'm not really Plex's biggest fan, I have to say, but I know that a lot of you are, so let's do that. Now, let me show you how easy it is to set it up. Click on the App Store and search for Plex. Don't click on Install, but on the app itself. Then click on the little arrow next to the Install button and choose the Custom option. Then here there are two things that we need to do to change: the volumes and the devices. For the volumes, click on the target under ZimaOS. I am creating a folder called Apps with a subfolder Plex, which is the name of my app, and a config folder inside. And by the way, this is going to be the kind of the pattern that I'm going to be following for every single app that I'm going to be installing today, okay? Now, earlier, I created a folder called Media with a couple of videos of mine so that we have something to test, okay? Nothing too big. So now all we got to do is map these folders to the TV and movies categories respectively. And then finally, we need to map the /dev/drive folder to Plex so that it can access the iGPU. Then just click Install, wait a couple of minutes, and Plex is ready to be configured. And once the installation is complete, click on Plex and it will launch a new tab. Yeah, and this right here is the reason why I don't like Plex. Now give it a name and press Next. Then all you got to do is map the categories to the folders that we mapped in our OS. And once that's done, click on Next and your Plex server is ready. If you want our direct transcoding, you need to pay the monthly fee. Otherwise, and I don't really have one, so I couldn't really show you how to do that. Okay, now we're going to have some fun. Now, this thing right here is a TPU or a tensor processing unit. And if your GPU was a car engine, this thing would be the equivalent to this. And I kind of feel like Morpheus talking to Neo right now. Now, if you're lucky, you can get one of these things for as little as 24 bucks. But make no mistake, despite its size, you can run certain AI models 2,000 times faster than a CPU. In particular, when combined with the PCIe Express slot right here at the top, like so, this way, I'm seeing this thing the other way around, like that, you can do some pretty nifty things with this thing. This just opens the door to a lot of fun. Now, thanks to this device, we'll be able to install a surveillance system that performs object recognition. And the software that we are going to be using is called Frigate. Typically, before installing Frigate, we would have to install the drivers for the Edge Coral TPU. However, this dude right here requested it on Icewhale forum, and Jerry from Icewhale was, kind enough to incorporate it in the ZimaOS kernel for version 1.4.1. Make sure you guys send Julio and Jerry some flowers because they saved us a lot of work. Now, to make sure that your Coral Edge TPU is installed and actually supported by your ZimaOS, you need to run the following commands. Just go into a terminal window and run lspci-nn pipe grep 089a. All these commands, by the way, are available on the blog that I'm going to be posting, so you can just go there and copy them. So if you get this output right here, you're in business. If you're not, it means that ZimaOS does not support it, so go on to the forum and ask Jerry to include it. Since Frigate doesn't exist in the App Store, we need to create a custom app which can either be in the form of a Docker Compose or a Docker CLI script. So click on the plus sign, select Install a customized app, then click on the Import button so that we can paste a Docker Compose file. Now, I have a Docker Compose for you that I tweaked a little bit, also from the one that Jerry recommended. So I've done a couple of changes on it, And you also will have to do a couple of changes yourself. For example, the volumes. Make sure that they match your own folder locations, okay? It's pretty obvious, but some newbies don't know that stuff. And another thing you might have to adjust is the SHM size, which is for the amount of shared memory. Now, this is set in bytes, and mine is set to around 256 megs. This number, of course, is predicated on the number of cameras that you might have. So, check the Frigate documentation. Also notice that I'm mapping my Apex device right here. Then hit install and again, go do something fun because this will take a while. Now, once you finish the installation, click on the three dots next to the app. Select Settings, Terminal, and Logs. And look for your username and password. Then click on Frigate, in the icon, and enter those exact credentials. Now, once logged in, change the password. Otherwise, you'll be doing this every time that you need to log in. And to do so, you just click on the cogwheel right at the bottom, go to Settings, and at first it might be blank, so you need to wait a little bit. And if nothing turns up, just hit refresh. I had the same problem when I first ran the script for some reason. So then click on Users, Update Password, and enter a brand new password. Now next, we need to add the camera configuration. And this part is the most laborious out of the entire ordeal, okay? If you check this link, Frigate provides you with a complete YAML, all of the options. But I made a very simple one for you here, and it's actually the one that I'm using too. So to configure the camera, click on the cogwheel at the bottom and select Configuration Editor. And again, if nothing pops up, just give it a refresh. You can then use the YAML that you see on screen or just copy it from my blog. It's important to notice that the detectors is set to PCI, and you need to change your camera, as in your actual physical camera, to RTSP mode, okay? And change the user and password. Some cameras have users and passwords, some other cameras don't. It will totally depend on yours. I'm using a Tapo camera that I use to monitor my garden room that I named Kitchen for whatever reason. Now, I could spend the rest of the video telling you exactly what each option does, which you can read on the amazing documentation that Frigate compiled. But I think it will be a lot more fun if we integrate this with Home Assistant on the remaining time that we have left. Just one thing that I want to show you guys before we set up Home Assistant. If you actually go to the Frigate's metrics, you can see that it's using the Coral TPU and the inference speed is around 11 milliseconds. And you can also check the logs to see that the TPU was actually found and it was loaded. But you might also notice that your CPU is being pushed quite hard. And this is because Frigate uses FFmpeg under the hood to transcode the incoming stream video into the format that it feeds to the convolutional neural network, which is what runs all this object detection stuff. But again, I don't want to get too technical. Just know that it's normal that you're getting, such high CPU. Your TPU is being used, but this is also quite intensive on the CPU itself. But anyway, Home Assistant. Before integrating Home Assistant, we need to first install an MQTT queue. It's almost like a tongue twister. This is just something Frigate will need to use to communicate with Home Assistant. It's just a very simple pub/sub queue, nothing more. And to install the MQTT server, first we need to create a config file for Mosquito, which is, I guess, the vendor's name for this MQTT. And I have the following structure, like I said earlier: apps, MQTT, and config. Then you can use something like Notepad++, for example, to create a file called mosquito.conf. And notice that mosquito has two T's. Then you need to copy these properties that you see here and paste it inside it. I'm leaving this as anonymous because it's running inside my private network, but you can always beef it up with a password if you wish. Just check the documentation. Then the same process as before. Use my Docker Compose file, which you can get from the blog post in the description, and make sure that the volumes match your system. Then you can just double check this is all working by checking the logs of the container, as I showed you guys earlier how to do. It's the same process. Next, let's update the Frigate camera config to ensure that it can publish into the MQTT queue. All we gotta do is go to Frigate, and in the configuration editor, change the MQTT from false to true. And the additional properties that you actually see on the screen, just save and restart. If you want to see if it's working, you can also open the MQTT logs and see that there is a new client connection to it from Frigate. We are lucky enough that it says Frigate because not all containers, state their name like this one here does. Now, we are ready to install Home Assistant. Open the App Store and search for Home Assistant. Then select the custom install like we did earlier with Plex. Then select where you want the config folder to persist. Change the network to bridge mode and add port 8123. You can use the YAML file instead if you prefer, it's in the blog. And then all you need to do is just change the volumes. Then just click on Home Assistant and register yourself by following the dialog boxes. Now, the first thing we need to do is install the MQTT integration so it can communicate with Frigate through the queue. So head to Settings, Devices, and click on Add Integration. Search for the MQTT integration and add the hostname IP address. Now, in this case, it's again the same IP address as your ZimaOS. We don't have a user or a password because remember I was lazy, so just hit Submit. You can also check if it's working on the logs of the MQTT container, just like we did earlier. Now next, since we are using the Docker version of Home Assistant, we will need to install the Home Assistant CS package. And to do this, you need to navigate to the terminal of your Home Assistant container, which is right next to where we see our logs. And then just follow what you're seeing on the screen. You need to run the following command, which is wget-o something, and the bash script to install that package. And once that finishes, just restart the container. Now, let's install the integration for the Home Assistant CS. After restarting, click on Settings, Devices, and Services, and Add Integration. And you need to look for the HACS. Tick all of that stuff and press Submit. Now, you see that code on the screen? You need to copy that. And then you need to click on the GitHub link. You're going to need an account for this, I'm afraid. And once you authorize it and you paste in the code, you paste in the code and you authorize it, the HACS will be installed. And I just restart the container, just in case. We're nearly there. Now, click on HACS and search for Frigate. Click on that and select Download. As you can see, it says pending restart. So you can either just restart Home Assistant or the entire container. It's up to you. I did the latter. Next, just click on Settings, Add Integration, and add the Frigate integration. Then enter the IP address for your Frigate installation and the username and password. Click on Submit, and voila, it should be working. When you click on Overview, you can now see your new integration. So from here, you can do loads of things like custom automations, turn on lights when people come in, etc. Because the TPU is performing the real-time detection. It's really powerful, this thing. Oh, and here's a bonus for you. If you want a custom dashboard card, just follow these steps. Click on HACS and search for Advanced Camera Card. Then select that and download. Reload, go to Overview, click the pencil on the top, and take control. Then you can add a new custom card and muck around with it. It's pretty cool, but I will leave the rest to you so you can figure it out and play around the things that you want to see on that card, okay? Because this video is already too long. We have a full-on NAS RAID-based server that we can use to connect via SMB client, or we can use as a Plex Media Server without a membership, of course, because life is better that way. A nice open source surveillance system monitoring my kitchen, aka my garden room, whatever. the sky's the limit, go nuts. And all of this with this, really tiny device that almost looks like one of those Walkmans from the 80s, like with the buttons here on the top. And this thing is worth a little bit over 100 quid, I believe, the 7700 version. The other one I think is around 60 bucks, but do check on the website. This is a very nice and compact unit that uses as much as 20 watts on full load with 2 HDD discs plugged in. And without the discs, you're looking at around 7 to 9 watts. And I didn't even mention that you can also run VMs on this thing, but I think that's kind of like pushing the envelope a bit too much. But if all you really want is just a small contained VM to do some tests or whatever, you can do it right here. Anyway, I had a lot of fun doing this stuff. I really hope you guys have enjoyed it, and keep tinkering. Don't forget to subscribe, and I'll see you guys soon. So take care.